Hello everybody, of course my name is Brian Downing. I am going to show you something that will hopefully blow your socks off. First of all, I just want to show you what we're dealing with on this Mac. We're dealing with a simple MacBook, 2.7 gigahertz, Intel Core, is that nice? 5, 8 gigs of RAM. So it's a pretty basic run-of-the-mill laptop. Now, I've gone through Intel threading building blocks examples. Now, it's the only parallel library that compiles within my Xcode, and it's just that good of a library to showcase what I want to show you. One of the examples you can use is called Seismic right here, and I'm just going to simply run it. And basically what it's doing is it's going to load up OpenCL, and it's going to open up all these different little touch places. So it's going to run using parallelization, multicore, to process these type of events and to carry through the effects using this OpenCL. So if you want more details on it, let me just pull up the Readme file of this. Okay, so this is key here. Now remember, this is running in C++ for Mac, Windows, and Linux. This is seismic wave simulation demonstrates use of parallel 4 and infinity partitioner. Example can be built to offload version to run on Intel Mini Integrated Core architecture based on coprocessor. Okay, so I'm going, what the hell is that? That's what appears to be the competitor to answer to the GPU onslaught from companies like NVIDIA. Now, I played with the NVIDIA, but you are tied back to a very restricted library that is pretty cryptic because it has to compile on the fly and blah, 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 blah. But this, I can't say for sure, but this seems to be more intelligent. And when I do further research on this, the first thing I want to show you, this is based off of the next generation of Intel processors. So we're dealing with Xeon Pi. But when I do a search on this mini integrated core architecture, you can see that this probably came out January 2014. So it's somewhat recent. Now, the other thing is when you look at the 59 reference, what's it saying? Well, what's it saying is that the 4-way SMT per core 512-bit SIMD instruction cache, blah, 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 L2 cache, 512K per core, and ultra-wide bus connecting processors and memory. And this is probably something you may have heard for high-performance computing, Knight's Corner instruction set as documented in 59, which is our multi-integrated core. So what does that mean? When we look at this, the advanced version, big hint number one, many Intel processor cores on a single chip. Interested of programming these cores can use standard C, C++, or Fortran. It's not available in any other language. Okay, this is only available in C++ here in this code that I've got. plist, GUI layer. So here's all the different code. Let me just go to the. So here's the actual code right here. Okay, I'm not going to go through it and show you what it does, but the point is that this is the ultimate fast way to let me repeat this. To offload version. So what you can do is you can take an instruction set and offload it onto this MIC architecture with this equivalent of GPU processing power without the restriction on what NVIDIA gives you. It's better designed and it's more recent than what NVIDIA is giving you. So this puts Intel light years ahead of anybody else. And of course, we can use this in our open source training platform now, using what's provided from Intel through their threading building block C++ library. Okay, I've talked about it. This is huge because now, again, like, I don't know what I got offloading. So, and it, again, it's using L2 cache, as it said. The L2 cache right here. Where was it? Someone in, that was probably in the, coherent L2 cache. Okay, that's the fastest cache you can get. So now we have the ability to expedite our processing on level 2 L2 cache. So that's pretty huge. And now we are living proof of this working on my little laptop and building it with no issues compared to all the other solutions, be it in Python, NVIDIA, and God knows what else. But I can actually get it running on my Mac. This is a big deal from my point of view. So trying to understand this more, this kind of architecture for multi-threading. And again, the other thing is, again, I need to stress, it's only available for C++. Okay? As it says in here, only using standard C++. So there's no like wonky libraries that you need to deal with. Looking at the project in my Xcode, what we have here is we've got OpenGL dependencies and some others. I think the framework calls, but I can't guarantee it. But I'm not interested in the visualization yet, but knowing that it exists using OpenGL, this is pretty powerful stuff, but I don't want to go down that path because I'm not really interested in this because I'm sure OpenGL may not have what I'm looking for in terms of visualization for building out proper, different charting and stuff. I don't need to re-engineer or recreate the wheel there. Doesn't make sense. But for just throughput of hardcore processing with a lot of data, with this type of multi-core library on top of leveraging the power of what Intel's giving you now with these new architecture boards, MIC, this is pretty powerful. And as well, with all this fun stuff for the Xeon Pi processors. And it's built really for massive parallel multi-core processors. That's a pretty big deal. And now we can absolutely easily access it via this TBB library from Intel. Open source, I might add too. Really cool. So I'm going to kind of probably lean this direction. And as I dig deeper in it, it just gets better and better. I just thought I'd let you know about it.